This video will cover the first page of notes on the topic of radical equations. For this page, I kind of fold the page vertically so that I can get two columns. On one side, we will actually write down the steps to solving radical equations, and on the other side, we will actually do an example. In order to solve radical equations, we're going to have 5 steps. The first step is going to be that we're going to isolate the radical. So when we isolate the radical in our example for solving the square root of 11 minus x is equal to 1, then what we're going to do is we need to get the radical by itself. So I'm going to add x to both sides. So now that I have the radical by itself, the second step is going to be to get rid of the radical. In order to get rid of the radical, what we want to do is we want to get one set of parentheses on the left and one set of parentheses on the right. Depending on the index of my radical, so in other words, if this is a square root or a cube root, that will decide what I need to power it to. So if it's a square root, then this will be a square. If this is a cube root, then we're going to cube. In our case, we have the square root of 11 minus x, so we're going to put a parentheses on the left and square it. We're going to put a parentheses on the right and square it. Notice I did not put little parentheses and square every little term. It's actually going to be one set of parentheses on the left, one set of parentheses on the right. So on the left, we're going to see that the square root of something squared is the same thing as the square and the square root eliminating each other, and I just get 11 minus x. On the other side, on the right side, I do not have anything that will cancel out with the square, so I actually have to think of this like FOIL. So this is the same thing as x plus 1 times x plus 1. So I'm going to use FOIL and find that on the left I still have 11 minus x, and on the right, after doing FOIL, I have x squared plus 2x plus 1. So now let's go to step number 3. But before we can go to step number 3, we need to ask ourselves, do we have a radical? In our case, we don't. Notice there are no radicals in what we have after we did our FOIL and got rid of the square root. So we're going to go to step number 3. Our job is to solve for x. Remember, if you have a quadratic, you may want to try factoring. So we look at our equation, and we do have a quadratic. I have an x squared. So what I'm going to do is I'm going to bring everything to the right side, so that way I still have a positive x squared. So I have a positive x squared. I'm going to add x to both sides. So I'm going to add x to both sides. That's how I get my 3x on the right. I'm going to subtract 11 so that these cancel out. So I'm going to subtract 11, and that's how I have negative 10. And on this side, I took everything away, so it just has 0. But remember, we can also put the 0 on the other side using that duh property, that if I have a is equal to b and b is equal to a, that means the same thing. So I have 0 is equal to this quadratic. I can write it as the quadratic is equal to 0. We still need to solve. Remember, we kind of hinted that if it has quadratic, then we should use factoring to try to solve it. So I'm going to solve it by factoring. So x squared plus 3x minus 10 is the same thing as x minus 2 times x plus 5. I'm going to set each of those factors equal to 0 and solve for x. So I'm solving for x and I'm solving for x. All right. So we found that x can equal to 2 or x can equal to negative 5. We're going to go to step number 4. Step number 4 is to check our solutions with the original equation. My students always ask me, why do we have to check our work? Well, we have to check our work for radicals as well as rational functions because of the domain restriction. We didn't do a domain restriction here, but we know that if we have the graph of the square root of x, that graph would start here and go this way. So we know x cannot be any negative number, that the stuff inside of our radical cannot be negative. If it is negative, then we end up going into the imaginary world. So we want to make sure we stay in the real world. So to stay in the real world, we're going to have to check our answer into our original equation. So here's our original equation. So everywhere I see x, I'm going to put 2 because I'm checking and see if x is equal to 2 is a viable answer. So I'm going to have the square root of 11 minus 2 is equal to 1. I have my question mark up here to say that I'm trying to see if it's going to be true or not. So 11 minus 2 is 9. So now I need to look for the square root of 9, which is 3. And then I still have the minus 2 coming down, and then we see 3 minus 2 does indeed equal to 1. So x is equal to 2 is a good answer. I do want to point out here is that I know that when we had x squared is equal to 9 and we were trying to find what x was and we took the square root of both sides, you had to remember to take plus or minus the square root of 9 so that we can solve for x. In this case, because the problem states just the positive square root, then we're only going to look at the principal square root, which means the positive value one. All right, so let's take a look and see what happens if I plug in x is equal to negative 5. So I'm plugging negative 5 for the x. So notice I have 11 minus a negative 5 under the square root, and then I have minus, and then in parentheses, my negative 5. It's always a good habit that when you're substituting to make sure you put parentheses around your x value when you're doing the substitution, so you can clearly see that this was an x and this was an x. So now we're going to have the square root of 11 minus a negative 5. That's the same thing as 11 plus 5. That's the square root of 16, and the square root of 16 is 4. Over here I still have minus a negative 5. That becomes a plus 5. So now I have 4 plus 5. Does that equal to 1? And the answer here is no, it does not. So when we come back up here, we can see that we crossed out x is equal to a negative 5. That is what we call an extraneous solution. That means we found the number when we did the work, but we lost something in the transition. So that's the reason why we have to check. Another reason why to think about checking is that if we had the square root of x, we also know that the graph, we know that x cannot equal to the negative numbers. In other words, there is a domain restriction. So when you have functions that you're solving the equations to, and those functions have domain restrictions, you actually have to do the step number 4 of checking your solutions. Finally, the last thing we need to do is to actually write our solution set in curly brackets. So the one answer we had is that x can equal to 2. Notice I did not put negative 5. And that concludes this video.